Today, I'm going to show you how to prepare a polyhedral drawing style of a crystal structure like this. So, the first step is you need to have the Mercury software. The Mercury software is a very powerful software mainly used for viewing crystal structures. If you don't have a Mercury software at this point, you can download it for free in this website. So when you get to this website, click Download Mercury, and most of the functions are usable as a free version. And if you get a license, more of the function will be unlocked. I'm not going to show you the downloading and the installation process. You can follow the instructions to do it. The next step, you need to find a data set which you can draw a polyhedral structure with. So to draw a polyhedral structure, you have to have one central atom which is connected to at least 5 bonds. For example, in this case, the central lead has 6 bonds. It's an octahedral geometry. So this case, you can draw a polyhedral structure. If you have a data set to play with, you can open it now, or if you don't, just go to this website, WebCSD, and go to the simple search. Today I'm using one very generic, very common type of mineral crystal. The generic name is called perovskite. Type it in the compound name field, then press Enter. When the preview showed up, you click the first entry, then click Download Current Entry, and you choose the first option is fine, then click Download. Sometimes it asks you to provide some user information, and you can provide those information if you like, or you can just click Opt Out. You will come to this page, and then you check this box and click Download. Since I have already downloaded it, so I can skip this step. And now you just go to your Mercury program and open this save file. This is the one I just downloaded from the WebCSD. And when you open it, depends on the default style you choose. Most of the time it is ellipsoid, but you can try all the different styles one by one. For example, wireframe. It will show like this wireframe as the name implies. By the way, if you want to zoom in and out, just hold your right mouse button, push up to zoom in, and push and drag down to zoom out. So you want to zoom to appropriate size, and if you want to move it, you just hold your middle mouse button and drag and release anywhere you want to put it to. And if you want to rotate, just hold your left mouse button and move around. Okay. If you want to change the view direction, you can click axis A, B, C. Also, you want to show the cell axis when you do it. So if you click A, you know your view along A direction, and it's shown as a top left corner. And the other 2 axes are here. So when you click B, the top left corner indicates you are along B axis, and C and A are here. So let's continue to explore different style. The next one is camped stick. It's like this. The third one is ball and stick. This is quite common in a lot of the computational chemistry. And space fill and ellipsoid. Ellipsoid is the most common drawing style. Most of the time it is shown at 50% of the thermal ellipsoid probability. And the last one is polyhedral. This is the one I'm going to show you today how to prepare. So that is actually quite straightforward. You just choose it here. It shows like this. But normally you never see polyhedral drawing like this. You want to draw more than one unit cell. So what you want to do is click pack. Okay, by the way, when you open it up, you might see more atoms like this. So I actually hid a few atoms already. So when you open up, this is a chemical formula you will see. So if you don't want to see these carbon and nitrogen atoms, you just left click to select them one by one. Then right click on the selection, then go to show and hide, then hide atoms. You might need to do it twice because it may be some disorders atoms there. So do it again, right click, hide atoms. Okay, now you come to the same view as I shown here. Okay, so as I mentioned before, you never see a polyhedral drawing like this because you want to see a extended structure, polymer structure, not the monomer like this. So you want to go to calculate, packing and slicing, move this to the side, and you want to reset. Then you want to show the cell axis. Now because your view along A axis, and if you increase the packing toward the A direction, you will not see anything. For example, let me just check this pack and you will see the effect in real time. So if you increase in A direction, you will not see anything. Okay, but if you increase on the B direction, you will see you are extending this direction. Okay, and if you add to C direction, it will extend to this direction. Okay, so you can choose to add to B and C direction how many times you like. Or you can directly type in some numbers here directly. For example, you want to type 5. It will grow 5 as a repeating unit in the B direction. And if you type 5 here, it will grow 5 repeating unit in the C direction. Okay, so suppose this is how many unit cell you like and you are okay with it, then you click OK to exit this window. Then you want to hold your middle mouse button and move this up to the middle. Then if you don't want to see this cell axis, you can uncheck it. And if you feel like, okay, I want to add more in this lateral direction, that is a B direction, okay, then you can go back to the B direction. You can add to maybe 7, let's see. Then you click OK. Again, you hold your middle mouse button and move to the middle. Then the next step, I will show you how to customize your own favorite style. This is the default style or the style you set before. If you don't save it, it will revert back to the default style. In this case, it is the previous style I just used. But here I want to show you how to customize to your favorite. So to do that, you click Manage Style. Then you click New, and you want to choose the first selection. So basically use the current display setting as a template. On top of that, you can create and edit. Okay, here's a panel you want to do most of the customization. So first, the drawing style. So in this style, it is polyhedral and it is reflected here. For example, if you want to change to wireframe, you choose wireframe for the non-hydrogen atoms, you click Apply, it becomes wireframe. Of course, you don't want to do that. You want to use a polyhedral in this case. Okay, then you apply. The second thing is the color of these atoms. You can choose they are shown by element, which is the default setting, or you can choose by symmetry equivalence. Click apply to take effect, or you can change to symmetry operation, or you can use a monocolor for all these atoms. For example, you want to make everything red. Click apply. This looks like a red lantern, Chinese lantern. Okay, but in most of the cases, you want to choose to show the drawing by color. But you can choose whatever you like. This is just my personal preference. Okay, and this is the first selection you want to customize. And the second one is a display option. And here you can change the background color. For example, currently it is white, single color. But you can change the single color to any color you want. For example, you want to change to a violet. Click. You need to click apply every time to take effect. Okay, this doesn't look good in this particular case, but you get the point. You can change whatever color you want, or you can even change to gradient. And pretty much this gradient divides the screen to 4 quarters. And in each quarter, you can define a specific color. Then the program will generate a gradient transition from one color to another. For example, let's just play with it. Change the right top corner to yellow, right bottom corner to this light blue. Even here you want to change to red. Click OK, click apply. See this beautiful neon color. Okay. As a scientist, we probably want to make it the simplest background. Okay. Click OK, click close, click apply. Go back to our white background. Before I move on, you notice that here all these options are grouped into different groups and divided by these lines. So this line is display option, and this is element color. So here you can see all the elements have their default color. Here in this structure we have lead, bromide, and the bromide is here. You can change it to any color you like. For example, you change to green. Okay, apply. And the lead color, since lead is the center atom of this polyhedron drawing, this lead color will determine the polyhedron color. For example, currently the lead is this pink color. If we change to blue and you click apply, then this lantern will become blue. Okay, so you can play with all the different colors and find your favorite settings, or you can take the default settings they have on this periodic table. Okay, this block of the settings are specific to each individual style. The last one is for the polyhedral settings. So you could click to get into it, and you can see here we have the opacity. I currently put the opacity to be 18%, but you can crank up to 100%. Let's see how it looks. Okay, this is totally non-transparent. Okay, and I actually prefer a little bit of transparency, so I will make it, let's see, 50%. Apply. Okay, last thing I want to show you in this setting panel is the central elements and the ligand elements. So in this particular structure, lead is the central element, so it has to be selected. So in this case, all these light blue colored elements are selected already. It is also shown here. If you click it again, it will be unselected. And since you want to makes lead the center of the polyhedron, so you should select it. To demonstrate why you should select it, let's unselect it. And you click OK, click Close, click Apply. Now you see there's no polyhedral drawing because lead is not allowed as central elements there. So you have to go back to select it. So make sure lead is allowed as the central elements. Then you select Close, Apply. Now you can see the drawing again. Okay, when you tweak the settings and eventually find your favorite style, then click Apply and click OK. And now you will be asked for a style name. You can give a name like a poly, then user 1. Any name is fine as long as it reminds you of these settings. Then click OK. Now you look at this style manager. The last one is a newly generated, customized your favorite style. Okay, and you can always go back to editor to tweak further if you like. Okay, close to exit this window. Next, suppose you like this viewing and you want to put this in a paper. Then the next thing you do is go to File, Save As, and here you want to choose PNG, which is a lossless figure type, and basically when you resize it, you don't lose the quality. Okay, click Save. Normally you want to check this transparent background. Basically this background will be transparent. It will not be white. But if you uncheck it, the figure you save will have a colored background. In this case, it will be white. So personally, I prefer transparent background because you can put this figure on top of any other figures or text. And you choose this pixel image size, normally the lightest one. Then click OK. And if you go to your desktop, this is what you see. Okay. So the next step, I will show you how to save the current view for you to continue to work on in future. For example, if you exit the window by closing this window now, and next time when you reload the structure, you will see that mono unit cell structure again, but not this one. To save this particular perspective for you to continue to tweak on, for example, you want to rotate a different perspective, but you want to keep everything else the same. For example, you want to keep 7 of this in C direction and 3 in A direction and 3 in C direction. You only want to change a little bit, so you want to keep this perspective for your future reference. Then you need to go here, File, Save As, click. You need to choose this MRYX style. And now you click Save. Close this window, close this figure. And we have one is the original file, which is a CIF, file we downloaded from the website, WebCSD. And this is the one we just saved. It is the MRYX format extension. And if we open this one, the original one, you only see this starting structure, not packed structure. But if you open the one we just saved as MRYX, you will see it is the one before we exit the window. Okay, then it's much easier to continue your work on top of this figure rather than starting from the scratch as the original file. So in other words, the CIF file, you cannot modify it. You can only change the view, but once you close the window, all the settings will be gone. But if you save to the MRYX style, it will keep your settings like different drawing styles, panking, etc. Okay? So much for today.